This is El-Refaei, math teacher for both AS and A2 level. Today class we're going to talk about more logarithmic rules, and we're going to use them in the future classes to solve logarithmic and exponential equations and inequalities. We already explained 4 logarithmic rules. Today we're going to solve more logarithmic rules. I'm not going to explain how we did get these rules. My purpose for this class, how we're going to use them. Okay, if x and y are both positive and a is more than a 0 in the same time doesn't equal 1, a is the base, then the following laws of logarithms can be used. The first rule, when I have x and y and the relationship between them multiplication, I want to split them. When I split the two terms, the relation them multiplication, I will have addition, but I have to be careful that they both will share the same base. So log x by y to the base a equals log x to the base a plus log y to the base a. This rule can work in two directions, splitting and combining. Splitting multiplication gives me addition, combining addition two logarithmic terms sharing the same base, I will have multiplication. Second one, I have two values x and y. The relationship is division. If I want to split them, the division will give me subtraction, and the combining of subtraction will give me division. And I have to be careful that both sharing the same base. So log x over y to the base a equals log x to the base a plus minus log y to the base a. Third one, we already explained that I can move the power to become a coefficient. So log x power m to the base a equals m log x to the base a. The last one, log x, log 1 over x to the base a. When I flip the fraction and x become a numerator instead of denominator, the power becomes negative 1, and I move the power to become a coefficient, negative log x to the base a. Question number 1. You work out, use law of logarithms. First one, x equals 15 to the base 5 plus 8 to the base 5. First of all, it's addition, and they are sharing the same base. So x equals log 15 by 8 to the base 5 equals log 15 by 8, 120. Log 120 to the base 5 equals to three significant figures, 2.97. 2.97. Second, log 36 to the base 3 minus log 4 to the base 3. X equals its subtraction, and they sharing the same base. So I'm talking about log 36 over 4 to the base 3, which equals log 9 to the base 3 equals log 3 squared to the base 3. The power becomes a coefficient. So I'm talking about 2 log 3 to the base 3 equals 2 by 1, which equals 2. The third one, log 27 to the power 5 base 3. X equals log 27, it's a 3 cubed. All of it to the power 5 base 3 equals log 3 to the power 15 base 3. So 15 log 3 to the base 3 equals 15. The Fourth one, x equals log 1 over 1 over 256 to the base 4. 256 equals, I think it's 4 to the power 4. Let's check. 4 to the power 4 equals, yes, 256. So log 1 over 4 to the power 4 base 4 equals log 4 to the power negative 4 to the base 4 equals negative 4 log 4 to the base 4, which equals negative 4. The last one, x equals. Now I have two problems that I have a coefficient and addition, and the good news that they are sharing the same base. So I'm going to move the coefficient to be a power before I combine. Before I have to combine, I have to move the coefficient to be a power. So log 5 to the power 3 base 2 plus log 7 to the power 4 base 2. Then log 5 cubed by 7 to the power 4 base 2. To get the answer, base 2, I'm talking about 5 cubed and 7 to the power 4, which equals, oh, do it again, 2, 5 cubed seven, 4, 16,724. To three significant figures, 16,700. Round to be 16,700. Let's move to question number 2. Write in the terms of log x to the base a as an n, log y to the base a as an m, and log z to the base a as an o, expressed in the terms n, m, and or o. Okay. Log x to the power 9 by z cubed to the base a. I have to split them first. Log x to the power 9a plus log z cubed to the base a. Then the power becomes a coefficient 9 log x to the base a plus 3 log z to the base a. 9 x to the base log x to the base a is n plus 3 log z to the base a is o. Double I have to split them first. The division gives me subtraction. Log x to the power 4 base a minus log y to the power 9 base a. The power becomes a coefficient for log x to the base a minus 9 log y to the base a. So I'm talking about 4n minus 9m. Third one. log the fifth root z to the base a minus log x to the base a. The fifth root gives me a power 1 over 5. Log z to the power 1 over 5 to the base a minus log x to the base a. The power becomes a coefficient 1 over 5 log z to the base a minus log x to the base a. 1 over 5 o minus n. The last one, log LA to the power 5 base a minus log y squared to the base a. 5 log LA to the base a minus 2 log ly to the base a. Log LA to the base a gives me 1, so 5 minus 2m. I hope today's class is clear. I'm going to use this rule this next class, solve more exercises. See you in the next class. See you then.